Stop, the 1952 Sahara discovery that changes everything. Stop, the radio clipped the word in the dark. On a 1952 Sahara line, needles jumped, the pen tore through paper, and the crew froze. Seismic returns looked like open ocean under stone. Night vents blew air that felt wrong, cold, metallic. A magnetometer wandered until the operator slapped it. Then the field chief called it, shut down, pull back, lock the boxes. Files went upstairs, maps were redrawn. Months later, a quiet agreement closed the sky over a rectangle of sand. The Nubian Sandstone Aquifer was real. Oil surveys had hit something else, and one machine, if it was a machine, kept humming. 1952 field panic, what the instruments showed. To understand that order, go back to a wind-scraped ridge in the eastern Sahara. It's late afternoon. A Shell BP joint crew has laid out a seismic refraction line across what the concession map calls stable dunes over Nubian sandstone. They're chasing anticlines for oil, not water. Charges go in shallow boreholes. Cables stretch like black veins. The geophones tick like crickets. Stakes, if the subsurface isn't what the model says, you can lose men and rigs to sudden subsidence. Insurance only tolerates so much unknown pressure before premiums jump and coverage vanishes. The camp cook hears the word blowout and stops laughing. Shot 1. They expect crisp first arrivals, velocities climbing as waves pass from loose alluvium to sandstone to basement. Instead, the first breaks smear. Travel times stretch, curve, then drop fast, as if the wave fell off a shelf into something that swallows energy. The interpreter marks picks, erases them, and starts again. He's trained in 1940s refraction tables. Nothing fits. The inversion tries to solve for velocity and spits out numbers that belong to water, not rock. Ocean-like impedance beneath confining layers. That's not on the scouting brief. The field geophysicist, a man who chews the same pencil until it splinters, radios base. Velocities inconsistent with oil-bearing sandstone. Possible high-pressure confined layer. He wants permission to widen the spread to cross a suspected Paleovalles axis. Headquarters says proceed, but keep to budget. Money, not mystery, is in the loop. They shoot again. Same curve. Then the magnetometer, an old fluxgate that usually hums through heat haze, starts to wobble on one grid square. Magnetic noise clusters in a way that suggests nearby current, not geology. The instrument tech swaps batteries, then the whole unit. The wobble moves with the position, not the tool. He notes drift and circles the coordinate. At dusk, desert temperatures fall. A gully between dunes exhales air that isn't warm. Two laborers joke about ghosts, then go quiet. One says it smells like wet basalt. Another says there's a faint hum if you press your ear to the sand. Field lore forms fast when people are scared. Action tightens. The crew lays a short reflection line to test what refraction is hinting at. In 1952, reflection gear is heavy and temperamental. Still, they get a few gathers. Hyperbolas should reveal nice, predictable layers. Instead, portions of the return are damped, as if a blanket sits over a cavity. The interpreter leans in. Internal multiples decay too quickly. Signal disappears where the model says it should be lively. He sketches concentric shapes, erases them, then draws them again. On the third day, a scout truck noses into an interdune corridor that locals avoid. The compass flutters a little left of north and won't settle. The driver marks it down to the truck, taps the gauge, and keeps going. The radio picks up a low-frequency carrier that rides under voice. No station, just a tone. The operator calls it atmospheric. The tone doesn't change with distance. Impact lands in paperwork. The insurer's man in Cairo gets a cable. Anomalous pressure indicators, potential subsidence, request to suspend blasting near grid R17. He faxes back a promise to review. Then he quietly raises the policy threshold for catastrophic geologic event. Crews hear rumors that if anything collapses, coverage evaporates. Men think about families and get careful. Unknown to the line boss, government geodesy teams have been logging gravity anomalies in the same district. The numbers are small but consistent, density gaps that don't match mapped lithology. Their reports sit in a colonial office, stamped confidential. The oil guys have their own vaults. In this period, refraction, reflection, and borehole logs rarely meet each other outside boardrooms. Silos keep stories from connecting. Meanwhile, a borehole planned as a shallow stratigraphic test hits damp sandstone earlier than expected. The driller doesn't shout "water strike." He calls for a pressure gauge. The head isn't gushing, but there's lift without pumping. Artesian hints in a place the map says closed basin. He photographs the gauge, stows the film, and writes "See me" on the log margin. Later, that film will be misplaced in a merger. The lead geophysicist has a choice: write the truth and risk losing the oil program, or tamp it down, hold the concession, and get time to look again. Contracts mean access. Access means data. He frames his report carefully: anomalous velocity inversions consistent with saturated, confined units. Recommend wider survey before deep drilling. It's a hedge. He hopes it buys days. Complication tightens the loop. The same grid square crashes a generator twice in one evening. An oscilloscope shows a tremor in the power that no one can source. The electrician blames dust. The mechanic cleans contacts, then swears the alternator is fine. The hum in the sand is louder when the wind dies. No one admits to hearing it. Impact ripples outward. Transects are halted on 2 lines. Procurement requests for extra cable get deferred pending reevaluation. A company man arrives and boxes the field notes. Standard archiving, he says. They never come back. Later, independents will shuffle ministries, libraries will lock stacks, and those coordinates will become smudges. To explain why veterans got spooked, you have to pull the camera back 12,000 years. The Sahara wasn't always this. Climate snapped. Lakes swelled, then died. Water moved, then froze underground. The signatures the crew stumbled on had a memory older than maps, and maybe, if the crew's night stories hold, older than geology alone. Younger Dryas and the Green Sahara memory. To understand why veterans got spooked, you have to go back to the hinge in climate. Around 12,800 years ago, the Younger Dryas slammed a brake on warming. In North Africa, that snap didn't just lower temperatures. It rerouted winds, shifted monsoons, and turned thresholds into doors. What was scrub desert in one century became meadow and lake in another. The Sahara wore green like a season. Stakes look simple on paper and brutal on the ground. When rainlines move hundreds of kilometers, rivers either wake or die. People are forced into new math, compress around water or walk toward rumors of it. A tribe that can read a shoreline buys a century. A clan that misreads a dune loses one in a generation. Abrupt climate isn't a graph, it's a border that moves while you sleep. Action is written in stone and sand. Across the Sahara, Paleolakes left rings you can still trace with a finger from orbit. Shorelines curl around basins that are dry now but held waves that broke for centuries. The Great One, what we call Mega-Chad, sprawled like an inland sea. From the Eneti to Tibesti, abandoned deltas and inverted riverbeds march east and west, proof that water once braided through the desert and then buried its own tracks. NASA's orbital eyes caught the ghost rivers. In the 1990s, the spaceborne imaging radar on the shuttle painted the ground with microwaves that slipped through sand. Where the human eye saw a blank dune, SIRC and XSAR drew maps of old drainage, wadis, fans, meanders, inked as if yesterday. That data set didn't just redraw the Sahara, it gave names back to basins that had forgotten theirs. The radar stitched a memory. The Green Sahara wasn't a myth. It was a living system with arteries and a pulse. Impact sits under the dunes now. Those humid periods recharged porous stone, Nubian sandstone that drank when the monsoon pushed north and held when it retreated. Diatom beds, the glass skeletons of lake life, still lie in the dust like spilled sugar. Fossils of fish and hippo, cattle and antelope mark shores that no longer exist. The aquifer's isotopes date to those windows. The water in deep wells whispers a birth date from the African humid period, not from any recent rain. Evidence multiplies when you stare. From satellites, you see dune fields sculpted over buried valleys. Their crests align with winds, but their feet drape over channels that once ran wet. On the ground, you find stone lines that don't make sense until you step back. Cairns that mark springs gone dry. Low walls that slow sheet flow. Slabs that look like art until you realize they catch dew. Memory is practical when survival requires it. Humans didn't just witness this, they organized around it. Nabta Playa out on the Nubian desert floor holds stone circles laid down with an eye for the sky. Alignments line up with solstices and star risings. The site sits on an ancient playa that filled and emptied with the pulse of monsoons. The people who met their herded cattle carved basins and placed markers that said, "Here water returns." Rock art far to the west shows boats rowing across what is now gravel plain. In Tassili and the Tadrart, cattle cults paint a story of steady hands and planned seasons. What nobody knew at the time, what our 1952 crew could feel but not name, was how that memory embeds in stone. When humid centuries ended and the rainline fell south, much of that water went underground. Confined by clay-rich layers, head built quietly. Pressure stayed even as surface rivers flickered out. The Green Sahara didn't die, it hid. Meanwhile, societies adapted in cycles. As the Holocene warmed again, patches of the Sahara breathed, lakes returned, then receded in pulses. People tracked those pulses with movement and with work. Qanat-like galleries, later called Fagara in the Maghreb, would appear much later, but the logic is older. Map gradient, cut just above the water table, bleed pressure carefully. Even if those exact tunnels weren't here yet, the thought pattern was. You can hear it in the placement of camps around Paleo Springs, and in petroglyphs that cluster on spillways of now invisible lakes. Here's the open loop that pulls us forward. If people thrived in a landscape that turned on and off, did some of them learn to flip small switches? Not magic timing, celestial markers to predict monsoon advance, low walls to slow runoff into soak zones, subtle stonework at vent mouths to turn cold night air into condensation. We're not talking about turbines spun by legends. We're talking about thousands of little choices that, taken together, act like a machine. And then the climate swung again. Dry won. The Green Sahara retreated for good. The living network went quiet at the surface and loud below. The aquifer kept its head. The dunes marched over shorelines and sealed them. What our oil crew found in 1952 felt like a voice through sand because, in a way, it was pressure speaking the grammar of an older world. Modern states would stumble onto that grammar by instrument. Datasets would bloom and then close. Because once you grasp what sits under 4 countries, you inherit not just a map, but a governance problem. The next part of the story is how science rediscovers water and power tries to file it away. The Nubian Sandstone Aquifer, scale, pressure, politics. To see what those instruments were feeling, pull the lens wide. Under Egypt's western desert across eastern Libya, through northern Sudan into Chad, lies a stack of porous stones laid down when this land was river plain and shallow sea. That stack is the Nubian Sandstone Aquifer System, multiple layers, not one lake, capped and squeezed so long that water there holds a memory and a push. It is the largest known fossil aquifer on Earth. Vast, but not infinite. Stakes turn real fast when pressure meets a pipe. Confined layers create artesian head, water that wants to rise without pumping once given a path. In some districts, the head is modest, a few meters of lift. In others, it's enough to make a dry well breathe. That head is money, food, power, and trouble all at once, because the water is old. It recharged mostly during African humid period windows, not last season. You can tap it, but it doesn't refill on human timelines. Action runs through measurements. When hydrogeologists sampled deep wells in the 1960s and 1970s, isotopes like carbon-14 and chlorine-36 dated much of the flow to the late Pleistocene and early Holocene. Chemistry matched the story. Low salinity in protected zones, creeping mineral load where flow paths got long or mixed. Pump tests showed respectable transmissivity. These sandstones aren't tight. Heads bled slowly across hundreds of kilometers, proof of a connected system with baffles and windows, not a simple bowl. Meanwhile, states started tracing contours with intent. Egypt mapped head in the western desert oases and eyed insurance against Nile risk. Libya looked south to Kufra and Sarir and saw a lever, freshwater independent of coasts and rivers. Sudan sat over big slices of recharged rock but struggled with lift, logistics, and conflict. Chad held the downstream end of old basins and needed survival, not leverage. 4 flags, 1 stone mattress, and a legacy that predates them all. Impact is easiest to see in Libya because they built a visible bet. Starting in the 1980s, engineers drilled hundreds of deep production wells across Kufra, Sarir, Tazarbo, and Fezzan. They laid more than 4,000 kilometers of large-diameter pipeline north. The great man-made river turned buried head into urban taps and irrigated circles. Whatever you think about the sponsor, the proof was on the surface. Extraction at scale from the Nubian Sandstone Aquifer System works. The cones of depression around fields showed up from space. Constraint follows close behind. Draw hard on fossil water and you lower head. Lower head means pumps, energy, cost, and eventually dry wells. You also risk subsidence where clay's compact and the ground quietly sags. In coastal reaches, pulling too fast invites salinity creep. In desert interiors, mismanaged irrigation salts soils from the top down. The physics don't care about borders or slogans. The meter spins even when the paperwork says sustainable. Quiet shifts tell their own story. In the 1970s and 1980s, some national agencies published detailed hydrogeologic maps. By the 1990s and 2000s, certain layers of data, precise heads, transmissivity mosaics, stress indicators moved behind gates. Procurement lines showed up for regional borehole integrity and hydrostatic monitoring masts, but the output stayed thin. Satellite products talked about land use, not pressure. Academics complained about missing logs. Librarians shrugged and pointed to mergers and reorganizations. Politics wrapped itself around pressure. Water that ignores boundaries forces deals or fights. Egypt needed a hedge in case upstream Nile projects squeezed the flow. Sudan wanted leverage and food security but kept tripping on instability. Libya, under sanctions, treated fresh inland water as sovereignty made concrete. Chad needed any card it could hold. Each actor read the same map and drafted a different story. None could afford a neighbor's surprise tap near a shared window in the confining layers. Proof of leverage is in how carefully words are chosen. Officials talk about development corridors, oasis stabilization, desert greening, and strategic groundwater. They almost never say fossil. Fossil sounds like countdown. Strategic sounds like plan. The choice is deliberate. If the public hears ancient, finite store, they ask hard questions about equity, duration, and who gets to drink last. Meanwhile, engineers keep their language plain. Heads are falling here. Pumping costs rise there. This well's chemistry is drifting. That gallery's screens are clogging with fines. They see the system as a machine you can over-rev. Short-term pressure gains from shutting one field can help lift another. Badly placed high-capacity wells can starve shallow communities. A pipe laid for politics can outcompete a spring that held a village for centuries. What nobody outside a few rooms hears are the new maps. Composite products that blend gravity, magnetics, seismic hints, and sparse wells to forecast pressure corridors. Those maps control tenders and veto them. A dot on that layer can turn a drilling plan into a security file. The language is procedural, moratorium zone, survey deferral, restricted grid. But the meaning is simple. Somebody believes a wrong hole could unlock or unbalance something they can't fix. This was the moment the 1952 fear got a passport. Not because a hum under sand proves a machine, but because a connected, pressurized body under four nations is, in effect, a living system with rules. Break those rules and you pay. Respect them and you might buy decades of margin. Ignore them and you export crisis downwind and downstream. So yes, the Nubian Sandstone Aquifer System is a sea under stone. It carries heads set by rains that last fell hard before our calendars began. It binds neighbors whether they admit it or not. And the politics are baked in. Whoever maps pressure best decides where steel meets sand. The vanishing maps, or where it never will and why. While that pressure story was solidifying underground, something quieter was happening in filing cabinets. After 1952, the paper trail thinned in places where it should have gotten thick. You can feel the fingers that moved through drawers because the gaps line up with value, places where head was high, transmissivity clean, and access simple. Strategic blindness isn't an accident, it's a choice with beneficiaries. Stakes are simple. If you control the map, you control the tap. Miss a contour and you drill a dry hole. Hide a window in the confining layer and you hold leverage over a neighbor who doesn't know it exists. For new states carving ministries out of colonial shells, inheriting partial records meant inheriting someone else's plan. In a region where freshwater is bargaining power, a missing sheet is a weapon. The action looks bureaucratic, but it lands like a boot. In the late 1950s and 1960s, oil consortia consolidated concessions across the Sahara. With mergers came records integration, a phrase that moves boxes from site bungalows to city basements. Archives were triaged, seismic and petrophysics labeled core business, odd anomalies filed under miscellaneous. Then came corporate rebrands, asset swaps, and the slow evaporation of institutional memory. A field notebook that smelled like diesel ended up inside a legal envelope marked privileged. Meanwhile, independence changed letterhead but not the habit of compartments. Colonial survey offices became national geologic institutes. Some staff stayed, others left with what they could carry. In the shuffle, inventories were redone. Sensitive materials, anything that hinted at border-spanning pressure corridors, were lifted into restricted stacks. Researchers found their bibliographies dotted with "on file with the ministry," a phrase that can mean either safe or gone. Impact shows up decades later when you notice which maps survived. Aerial photo mosaics? Many. Surface geology at broad scale? Plenty. But the detailed overlays, the ones that paired gravity lows with shallow artesian shows or annotated seismic with high damping zone, avoid blasting, those went quiet. University libraries that once circulated colonial-era reports now list them as reading room only. In some capitals, the reading room opens 2 days a week, guarded by a man with no keys. The paper trail, when you do catch it, tells on itself. Company annuals in the 1960s celebrate rationalizing archives. Government gazettes from the 1970s announce new hydrogeology series sheets that never number past 5. A National Library catalog lists a 1954 Eastern Desert Geodesy supplement, but the call number yields an empty folder and a shrug. Ask why, and you'll hear about floods, fires, and renovations. All true sometimes. But the pattern clusters around the same rectangles the 1952 cruise circled. Then there are the whispers that live in pilot bars and way station cafes. In the 1960s, pilots ferrying parts to remote strips talk about no-fly rectangles posted with radio silence. You stray near one edge and a voice you don't recognize tells you to turn. Unmarked airstrips appear where maps say Dune Sea. Listening posts sprout from berms in the middle of nothing. The call signs change with decades, but the rectangles don't. Who benefits from thinner maps? Start with the obvious. If cheap freshwater breaks coastal desalination's monopoly, a lot of capital loses its rent. Firms that plan for decades of desal sales prefer a narrative of scarcity with metered relief, not a sudden inland source that undercuts price. Petrostates built on exporting energy don't rush to empower neighbors with water that reduces dependence and changes migration pressure. And any military planner loves a desert with controllable corridors and known blinds. There's a cleaner motive too: liability. If you publish a precise head map and someone drills, unbalances a system, and triggers subsidence or salinity creep, they can point to your sheet in court. If all you release is a broad brush, you can say you cautioned. Restriction is cover. It's also leverage in negotiation. We'll share the good layer when you sign the thing we want. We should be honest, not every gap is a conspiracy. Archives rot from negligence. Budgets get cut. A box of acetate maps stored under a leaky air conditioner turns to paste. A war empties a ministry in an afternoon. A reformer orders digitization, then the vendor folds. But when the same classes of data go dim across borders, years apart in the same pressure corridors, you stop blaming humidity and start asking who said no. Paper leaves fingerprints even when pages vanish. Procurement tells you what someone is building. In the 1980s and 1990s, tenders appear for remote communications masts, regional hydrostatic telemetry, desert perimeter lighting with no public user attached. A mast with no network, telemetry with no published stream. You can smell an invisible program, fence the rectangle, watch it, and make sure nobody else watches closer. This is where Libya's gamble matters. By dragging the Nubian Sandstone Aquifer System into steel, concrete, and international newsprint, the great man-made river turned an argument into a precedent. Extraction at scale left satellite fingerprints nobody could erase. It forced neighbors and vendors to admit, quietly in back rooms, that pressure corridors exist and can be tapped. And it triggered a countermove. If you can't deny, you can delay, deflect, and compartmentalize. Back at the 1952 grid square, the absence is the loudest thing. Field sketches that referenced ring damping and compass drift are referenced in later memos, but the originals sit behind security stamps or not at all. A junior geodesist's gravity notes match a later satellite solution to 4 decimals, but his bound notebook is cataloged as mislaid during reorganization. Even the index cards went missing. Somebody erased in pencil, not ink, quiet enough to be plausible, careful enough to steer steel away. Why? Because a comprehensive public map of pressure and anomalies would turn a rectangular patch of Sahara into a bargaining chip for everyone, not just a few. Cheap inland water would bend migration, soften bread prices, and shift leverage from coasts to oases. That threatens entrenched revenue streams and neat diplomatic hierarchies. So the maps didn't burn, they blurred. And yet the ground remembers. Cones of drawdown, satellite thermal hints, pilots, detours, Tuareg routes that skirt bad ground. All of it traces a pattern that paper tried to hide. The next move in the story is what happens when one country refuses to keep the secret and lays pipe anyway. Libya's great man-made river, proof and backlash. While the maps blurred, one government drew a line in pipe. Libya didn't wait for permission slips. In the 1980s, engineers set rigs on the Kufra and Sarir plains and started punching holes 500 meters down into Nubian sandstone. They weren't chasing oil. They were tapping head. Trainloads of prestressed concrete pipe followed, 12 meters long, 4 meters wide, stacked like chalk rolls from horizon to horizon. The plan sounded like a dare. Move buried Pleistocene rain to the coast and make cities drink desert. Stakes couldn't be higher for a sanctioned state. Sanctions meant parts were scarce, financing was political theater, and every failure would be public. But the upside was sovereignty cast in steel. If freshwater could flow no matter what ships did in harbors, if farms could green regardless of export markets, the calculus in Tripoli changed. People who'd grown up rationing water watched bulldozers clear swaths wider than highways, and they understood the promise without a single speech. Action ran like a convoy. Drill strings chewed through overburden into porous sandstone. Completion screens dropped, heads measured. Some wells breathed with no pump at all at first start, just a controlled rise to head level. The pipe crews laid more than 4,000 kilometers of trunk and branch. Valve chambers the size of houses punctuated the lines. Reservoirs rose outside cities that had never held a lake. The first flows reached Sirte and Benghazi, then Tripoli. You could see it from space. Dark circles of pivot irrigation blooming in Kufra, ribbons of dampness where desert had been absolute. Engineers documented the numbers with the quiet pride of people who like gauges more than slogans. Transmissivity held in the sweet spots. Drawdown cones widened but behaved. Chemistry stayed within expected ranges. Low salinity early, slow drift as fields matured. Maintenance logs noted screen clogging with fines in some wells. Acidization cleared them. A national project manager carried a battered binder with dates and flows, a personal ledger of proof. Impact wasn't just agricultural. In cities, taps ran at hours they hadn't before. In neighborhoods where people used to queue for tanker trucks, children filled buckets at home. Markets absorbed local produce from new fields, wheat, alfalfa, vegetables. Urban planners redrew growth limits because the water ratio per person changed. Farmers who'd gambled on boreholes that sometimes failed now had a pipe that didn't. For a time, it felt like the desert had agreed to a truce. Then the backlash showed its teeth. In 2011, as conflict swept the country, strikes hit pieces of the great man-made river network. One attack cratered a pipe factory that turned out the massive cylinders the system depended on. Another strike damaged a control facility. Arguments flared instantly over intent, tactical necessity, or pressure on civilians by squeezing water. Official statements pointed one way. Satellite images showed broken infrastructure and halted sections. On the ground, technicians tried to reroute and patch, while artillery thumped in the distance. The lesson cut through politics. Extraction at scale is real, and that reality makes infrastructure a target. When water equals leverage, pipes become front lines. The great man-made river proved the aquifer's capacity in public, but it also proved vulnerability. A projectile can undo a year of trenching in a second. A valve house is easier to hit than a buried wellhead. A society that drinks from one spine discovers how fragile a spine is. Beyond the flashes, subtler backlash arrived in memos and tenders. Vendors who once courted the project grew cautious. Export approvals for high-lift pumps and specialty screens slowed under new headings. Insurance for pipe yards climbed. Data releases tightened. International agencies lauded water access progress in one paragraph and urged sustainability reviews in the next. It read like concern. It moved like a brake. Inside the maintenance crews, another thread emerged, one that tied back to our first rectangle of sand. Drill logs from certain fields mentioned non-geological anomalies. Notes about odd thermal readings at night near vented risers. A field foreman wrote that a maintenance team heard a low sound under a still desert, a tone that disappeared when a diesel generator kicked on. An engineer flagged sporadic compass drift near a valve cluster nowhere near known iron. Separate notes, different years, same ring. Open loop then. The project turned buried head into public water, but it also forced more instruments into the field, more ears onto the sand, more eyes on the gauges. Anomalies multiplied with attention. Some had clean explanations, bad bearings, temperature inversions, instrument errors. Others refused to stay in the box. They formed a pattern that stretched back to the 1952 grid square nobody could explain without admitting there might be design under the dunes, whether human, geologic, or both. And yet the practical truth held. Libya's gamble fed people and lit homes. It also taught neighbors that you can pipe ancient rain at national scale. Egypt, Sudan, and Chad took notes, each within its limits. The world saw both the promise and the risk. Pressure can be harnessed, but control invites conflict. In the wake of strikes and repairs, the crews went back to turning valves, measuring head, and logging flows because water doesn't care about our arguments. It moves along gradient until we ask it to stop. The grid's shape, seismic M gravimetrics. While Libya laid pipe, a quieter campaign unfolded on laptops and survey trucks. Redraw the rectangle with physics, not rumor. Crews went back to the old coordinates with newer toys, and the ground replied with a shape that didn't read like chance. Concentric hints, rectilinear voids, zones where signals died without a clean geological reason. If shape implies intent, intent implies authorship and risk. Stakes sit in the implication. A natural collapse has ragged edges, scars that wander. A designed cavity prefers symmetry, repeating gaps, and regular spacing of features. If you're a planner, those differences decide whether you drill, detour, or fence. If design exists, even as an echo, a wrong vibration, a mistimed blast, could wake a pressure game you don't control. If it's only geology, the rulebook is different, but the penalties for guessing are the same. Action starts with what metal and math can hear. Passive seismic arrays set out across the suspected grid recorded microtremors day and night. In most deserts, the Earth hums within a familiar band set by wind, distant surf-like microseisms, and human noise. Here, the spectrum dipped where it should have peaked and peaked where it should have been flat. Low-frequency energy, steady and monotone, rode under normal desert quiet. When trucks idled, the tone faded. When they switched off, it returned, gentle but insistent. Interpreters penciled isochrons around patches of damping that formed rough rings, then boxes inside rings. Active seismic played stranger. Sweep a vibro-sized truck across clean sandstone and your reflection gathers line up in layered smiles, hyperbolas that resolve to neat strata. Across the rectangle, first breaks came late in annular bands, as if a halo of slower material or empty space sat beneath a consistent depth. Beyond those bands, reflections sharpened again. On profiles, that meant bright, dim, bright, concentric contrast, not a gradient. A senior interpreter drew a bullseye where the client had expected a uniform bench. Electromagnetics offered another angle. In arid sands, conductivity is low. GPR sails shallow and clean until dry attenuation wins. But near the grid's heart, ground-penetrating radar returned an odd silence sooner than models predicted, as if fine-grained, moisture-bearing lenses or engineered fill soaked energy. At the same time, frequency domain M at longer wavelengths mapped rectilinear zones of lower apparent resistivity that ran at right angles, too straight for dune swales and too persistent for random clay drapes. Rectangles nested inside wide, faint rings. Gravimetrics tighten the sketch. Gravity don't lie about mass. Fly a gravity gradiometer or tramp a base station loop across dunes, and you pick up tiny tugs that betray density differences. The rectangle's inner belt showed a smooth negative anomaly, light underfoot, bounded by gradients that changed too cleanly to be only paleokarst. Natural karst eats along fractures and makes chaotic voids, but here the lows traced arcs that met straight segments at consistent angles. Not perfect, nothing in earth science is, but regular enough that independent teams over years drew near-identical closures without seeing each other's drafts. Meanwhile, magnetics didn't behave like a pure basalt story. Yes, outcrops and subsurface flows can bend compasses and kick flux gates, but the anomaly here pulsed in clusters that marched along the same rectilinear lanes seen in M. Day-to-day variation tracked windshielded hours, not temperature alone. When a sandstorm buried a sensor, the baseline drifted only after the storm settled, like a system that disliked being watched. Field notes compass lazy. Drift returns when quiet, stacked up across seasons and crews. Methods fought limits in dry sand. GPR loses depth fast in quartz dunes unless moisture or fine clays help carry the wave. So crews stitched multiple methods. Passive seismic to hear the low notes, controlled source audio-magnetotellurics to paint conductivity at depth, gravity to anchor density, sparse refraction to bracket velocities. Models were built, broken, rebuilt with the same friction. To explain the pattern without intent, you needed a rare stack of coincidences that repeated across sites far apart in geology and history. Hypotheses lined up. A collapsed salt dome? Salt moves, makes concentric collapse and leaves low-density halos, but regional stratigraphy here doesn't favor thick halite at the right depths. An engineered cavity. That word lands heavy, better to say void field with regular geometry. Paleokarst labyrinth. Ancient groundwater eats limestone into mazes, sure, but the host units here are dominantly sandstone, with carbonate streaks too thin to carve such clean, repeating gaps. Basalt sills. They'd boost magnetics, not lower gravity so evenly inside rings. In the margins, field lore kept threading through. Diaries from different decades mentioned humming, audible when wind fell to nothing. Notes about cold air at vents on winter nights, denser than the ambient by feel, metallic to breathers, a word repeated enough to notice. Compass drift that settled when a generator fired, as if external noise masked an internal tone. No one published this in journals. They filed it in appendices or kept it in pocket notebooks, the way technicians protect reputations while refusing to forget. Impact moved from instruments to decisions. Survey lines were quietly rerouted around the innermost rings. Tenders for high-energy sources, bigger vibes, deeper shots were canceled without explanation. Imports for certain M systems hit additional review. A contractor who'd modeled the rings for a mining client got a call from a ministry asking who else had seen his render. Answer: just you. Reply: keep it that way. Scattered fragments widened the frame. Reports from UNAT Gilfkebir into the Tenere, across Fezzan and parts of the Eneti described cousins of the same geometry. Fainter, partial, eroded, but there. 15 sites is too many for coincidence and too few for a purely natural layer cake. Patterns across borders mean either a shared geology older than any flag, a shared hand older than any archive, or both. If the grid is a machine, it may be broken. If it's geology, it is an organized kind we don't fully catalog. Either way, the shape keeps telling crews the same thing. This ground doesn't like strangers with hammers. 15 erased sites, patterns across borders. While that grid held everyone's attention, something else was happening across the desert like the echo of a bell. Patterns started showing up in places that were supposed to be unrelated. Far-flung plateaus, empty depressions, and wind corridors that caravans had avoided for longer than anyone kept ledgers. 15 sites, give or take depending on who's counting, each with fragments of the same geometry. Rings that shouldn't be so round, lines too straight for dunes, and silences in the instruments where geology should have been noisy. Stakes rise when motifs repeat. One strange circle is an anecdote. 15 that share the same habits smell like design, or at least a rule we don't teach. And when those circles straddle borders, the politics arrive before the science. A ring in Libya is an engineering problem. A matching ring across Sudan, Egypt, or Chad becomes a negotiation about data, permits, and who gets to claim caution as policy. Action lives in vignettes. Near Kufra, west of the old exploration lines, an outer arc shows up as a broad gravity low with a neat gradient on its inner face. Flights over the sector record radio shadows, patches where comms hiss for 20 minutes, then clear as if you drove out of a tunnel you couldn't see. A Tuareg convoy shifts 2 days south to skirt a corridor elders call the Lazy Wind, a path where night air walks faster than it should and fires burn blue at the edges. Push east into the Gilfkebir. On satellite, the plateau's clean sandstone edges cast hard light, but a ringed depression at its flank holds a set of gentle, nearly concentric benches stepped like seats in a vanished stadium. Geologists tag it as differential erosion with a buried center softer than its rim. Fair. Then the M team traces rectilinear low-resistivity lanes that meet that circle at right angles and keep going beyond outcrop logic. A pilot who's flown mail runs out there since the 1990s says his compass gets tired in the southwest quadrant and only snaps back when he climbs above a certain altitude. Further south near Jebel Uinat, a cluster of basalt plugs breaks the monotony, black teeth and a yellow jaw. The obvious explanation is volcanic, but between the cones, a faint annulus shows in gravity, too smooth for a messy igneous field, and along its inner edge, scatterings of standing stones aligned to star positions that match the sky of 10,500 BCE, not today's. Archaeologists debate intent. Erosion moves rocks. Herders stack them for reasons that never make papers. Still, the alignments map to a processional sky, with an accuracy that keeps skeptics polite. West into the Tenere, where dunes roll like an ocean that forgot how to stop, an old French expedition report scratches coordinates over a note. Deviation du compas, souffle Freud nocturne. The published version loses the margin. A later Italian survey, working a corridor for manganese prospects, logs passive seismic damping in a belt 2 kilometers wide, then edits the line out of their glossy map. The contractor's field diaries, found in a daughter's attic years later, sketch a ring with a square ghost inside it, and a question mark she underlines twice. Fezzan contributes something simpler: habit. Caravans that once ran a direct path now break left to hug a chain of gravel rises. Ask why and you get a shrug. Bad ground, bad spirits, engines overheat, animals don't rest. A water trucker says the radio picks up a hum that sits under the music, and it makes the cab feel small, so he turns the wheel and buys himself silence. Practical superstition has a way of flagging physics. Eneti's sandstone labyrinths offer one of the cleaner cross-checks. Natural arches and towers throw fierce echoes in seismics and radar. Yet just north of a famous rock fortress, a broad, faint ring shows up again. Low gravity, subtle M contrast, passive seismic dips. And at 4 points around its rim, stone alignments point not at solstices, but at heliacal risings that would have mattered 5 precessional cycles ago. Local herders say the place is lucky for finding stray cattle and unlucky for camping. Documents betray a pattern of erasure. Expedition monographs from the 1950s through the 1970s include index maps with grid squares that vanish in the final print. Air photos have corner ticks but no frames. University theses cite grid withheld per agreement. What agreement? Requests for the originals draw courteous replies and then no more mail. In a few cases, second editions restore the missing tiles, but the tone dulls, compass drift becomes instrumental uncertainty. Cold vents become nocturnal katabatic flows. Witness testimony settles on the same sentences, years apart, languages apart. Pilots avoid shimmering radio shadows. Tuareg guides charge more to cross belts they call heavy. Mechanics say bearings fail more often in certain lanes. Surveyors mark their stakes and find them fallen in the morning with no tracks around, as if the wind got under them differently there than anywhere else. None of it wins a journal war. All of it keeps people from sleeping soundly on the wrong patch of sand. Impact cascades. Once you see the 15, you start looking for cousins. You find partial rings swallowed by dunes, rectangles half-sketched where bedrock breaks the circle, and a repeating distance between features that suggests a common template adjusted for local slope. The more those echoes pile up, the less defensible a pure chance story becomes. Either a widespread, organized geological process carved symmetric void fields across 1,000 kilometers, or human hands learned to work with pressure and stone at scales we don't credit to the Holocene, and pieces of that work still print on our instruments. What nobody wants to say aloud in the meetings is simple. If those patterns are aligned to star positions from 10,500 BCE, either somebody was watching carefully and setting markers to manage time and flow, or the alignments are a coincidence layered onto something older and weirder. Both choices force humility. Both argue for care. And both point back to one question that turns engineers into listeners. What function ties rings, rectangles, vents, and stars? The next step isn't to declare answers. It's to test the one use case that could tie them together without fantasy. Water moved by gravity and tuned by resonance, scaled across basins and centuries. If that's true, then each erased site isn't a shrine. It's a component. And the grid we keep tripping over might be a manual in stone, written for readers who knew how to hear the desert scaled up. If rings and rectangles are parts, what's the machine? Start small. Start with what people already built wherever rock, slope, and thirst met. In Persia, in the Maghreb, across the Sahel's fringe, people cut galleries along gentle gradients to tap a perched water table without lifting a bucket. Call them qanats in one place, fagara in another. The idea is simple enough to teach a child. Find head, keep it contained, bleed it slow. The elegance is in the math, not the mystique. Scale that logic to a basin the size of a country and the parts get bigger, not different. You need confined head to push, galleries to deliver, vents to breathe, valves to meter, and overflow to keep the whole thing from tearing itself apart in a storm year. The Nubian Sandstone Aquifer System gives you head for free, pressure set by rains that ended before writing. The job would be to draft a path for that head to do work on its way to relief. Precedent runs deeper than we admit. Romans siphoned across valleys, their inverted arches proving that water will climb if the pipe stays full and the downslope wins. Andalusian farmers stacked piezometric control into terraces so each field saw the same head. In the Sahara, fagara lines spidered out from oases, air shafts like perforations on a roll, each one a tiny decision point. More drop here, less there, bleed heat, catch dust. None of it requires steel. All of it demands discipline. Translate that to the rings. Picture a broad annulus underground, a pressure gallery encircling a softer center, fed by windows in the confining clay. Along that ring, vented risers pierce toward the surface at regular distances. At night, cold air drops through those risers, condenses moisture on cool stone, and gently pressurizes pockets where the ring breathes. By day, heat rises and the breath reverses. Over seasons, that breathing damps pressure spikes and keeps flow near constant, the way a bellows smooths a flame. Valves don't need bronze butterflies to work. A stone throttle, a shaped plug of dense rock seated in a narrowed throat, can meter flow if you size the gap to the head you expect. Lift it a finger, the downstream gallery wakes. Lower it, and pressure builds quietly toward the next relief. Ceramic sleeves handle abrasion and salts better than raw stone. Lime washes seal pores. Copper inlays, thin, not grand, resist biofilm in trickle zones. None of this is a miracle. It is maintenance. Overflow is where systems die if you get lazy. A flood year during a humid pulse could have turned galleries into cannons if there wasn't a way for excess to spill. That's where the rectilinear lanes make sense, not as roads, but as spillways and drains. Straight, slightly crowned, armored with fitted stone where flow concentrates, they'd give a surging ring somewhere to send its panic without chewing its own walls. When dry years returned, those same lanes would sit quiet, low resistivity ghosts for RM kits 1,000 years later. But can stone hold a gradient across kilometers without losing its mind? Only if you survey with care. This is where the sky joins the trench. If you need to keep a ring flat in a world that tilts, you mark time and align work to risings and settings that come back predictably. Celestial timing isn't worship in this context. It's a clock and a compass that doesn't rust. If your stone alignments point to heliacal risings that shift with precession, they double as a maintenance calendar. When the star hits the marker again, send crews, clear silt, check throats, lift the throttle 2 fingers, not 3. Materially, the desert helps. Basalt for hammer stone and dense valve plugs. Sandstone you can dress into blocks without shattering. Clay lenses to ram into seals. Lime you can burn from limestone streaks to make mortar and wash. Copper from modest ores traded along caravan routes, worked into thin, durable plates where dripping water would otherwise grow life that narrows a throat. Ceramic rings fired in kilns dug into lee-side hollows, sized to slide into galleries like beads. Now fold in resonance, the soft word the crews keep using when they say hum. A long, partially filled gallery can act like a Helmholtz system, a volume and a neck that prefer one note. Add slow, steady pressure from head and temperature swings at vents and you've built a thermoacoustic nudge. It won't spin a mill. It doesn't have to. All it needs to do is keep boundary layers agitated, discourage stagnation, and coax pulses to move down gradient without slamming. Low-frequency energy traveling through stone isn't fantasy. It's physics that masons feel in their wrists. Feasible only with survey precision, seasonal labor, and ruthless standardization. You don't cut 1,000 shafts unless you've solved how to keep sand from swallowing mouths and how to read fall in shadow. You don't hold gradients across a basin unless your horizon marks are sober and your crews repeat details exactly. Does that mean a single empire of engineers? Not necessarily. It could be a tradition, traded like a song, perfected at 15 nodes over centuries. Some nodes fail and are buried. Others keep singing through drought. Add one last piece, governance born of hydraulics. If rings are communal machines, they force rules. Who lifts the throttle at dawn? Who clears silt at the equinox? Who can tap the lane and who can't? Break the cadence and you starve downstream neighbors. Keep it and pressure stays kind. Scarcity writes law faster than kings do. In a dry century, a grid like this becomes a constitution in stone, and the humming underfoot is how you know people upstream remembered their lines. That's the leap, a scaled-up hydraulic tradition, not sorcery. Stone, ceramic, copper, head, gravity, resonance. A machine made of patience that could have fed regions and revived dead land. And if parts of it still breathe under dunes, they're breathing into our microphones now. Thermal and vibrational anomalies, heat where it shouldn't be. While the hydraulic picture was taking shape, another signal kept flashing at the edge of the instruments. A warmth where models demanded cold, and a tone where stone should have been quiet. Heat where it shouldn't be, and vibration nobody could source. If pressure is the grammar, heat is the accent that changes meaning. Stakes sit in that subtle rise. Heat thins water, lowers viscosity, and teases more flow from the same head. Great for a gallery meant to breathe, dangerous for a confining layer flirting with failure. Push a sealed system with just a little extra energy, and you can tip a pocket from patient seat to rush. In a desert, a few degrees at depth matters more than a speech in a capital. Action starts in orbit. Thermal satellites that usually see deserts as wide, even cool at night and searing by day, began returning pixels that didn't fit. Nighttime thermal inertia maps, those composites that highlight materials that hold heat, showed discrete blotches in dune fields sitting over known pressure corridors. Nothing volcanic at the surface. No dark rock to store the sun. Just gentle hotspots that persisted through seasons. Analysts flagged them as instrument quirks until repeat passes months apart hit the same coordinates, within the same shift. Like a heartbeat, you could draw a circle around. Zoom in and geology offers candidates. Buried volcanic fields can lie doggo under sand. Basalt flows and old cones mantled by dunes, radiating just a little more after sundown. Teams flew magnetic and gravity lines to hunt for those classic igneous fingerprints. Boosted magnetics, denser rock. They found some honest basalt teeth in places like Uinat, sure, but the soft hotspots didn't always marry the magnetics. In a handful of the rings, magnetics stayed tame while the night stayed warm by a whisper. That split deserves respect. Cross-check with radiogenic heat, the slow furnace in basement rocks. Granite rich in uranium, thorium, potassium throws off a predictable trickle. In the Sahara's crustal patchwork, those sources are patchy but mapped well enough to predict gradients. Where models said baseline, a few of the rings red plus a bit. Not a geyser, not a plant's waste plume. Just a nudge upward that lined up too neatly with damping belts to shrug away. Ground truth dragged the story from satellite to boot soles. Maintenance crews working vented risers in Libya, and scouts farther east on survey, logged night air that felt colder than the desert a few meters away, the way a cave exhales. In the same notes, they taped cheap thermistors to shallow probes and caught soil temperatures at 1 to 2 meters that sat a degree or two high after dawn when nearby sand had already given up the night's heat. Vents cold at the lip, ground slightly warm below. That's convection's signature, cells rising and sinking in a slow, patient churn. Fold in vibration. Mid-century logs had already muttered about a low-frequency presence. No source, steady, a tone you felt more than heard. Modern passive seismic arrays put numbers on it. Between wind bursts, a band near a few hertz stuck around longer than microseisms ought to in a desert so far from surf. Not a choir, one long note present at 3, then 8, then gone at 30 kilometers, like standing waves pinned by geometry. Engineers watched the spectrum sag when generators idled, then rebound when engines cut. Masked by noise, unmasked by quiet, a maintenance chief wrote, "Feels like the ground like silence." Impact is practical. A warm lens below a confining layer can free locked water the way a warm spoon coaxes honey. That glow, spread across seasons, could keep a ring's flow steady when surface swings would otherwise spasm the system. It could also sharpen pressure differences that tempt collapse along weak planes if someone hammers the wrong place. A steady low tone agitating boundary layers would discourage clogging in narrow throats, a self-cleaning trick no empire needs to explain in a manual. But that same resonance could turn a blast into a bell strike that travels farther than intended. Caution is mandatory here, separate explainable geology from lore. Some hotspots ride honest basalt at depth. Some cold vents are textbook katabatic flows pooling night air in gullies. Some compass drift is ironstone under sand. Field errors, calibration drift, tired gear, they write half the weird in any campaign, filter ruthlessly. What's left, stubborn across methods, times, and teams, are patterns. Gentle heat in belts that match damping rings, low notes that survive silence, vents that breathe out of phase with the air around them. Meanwhile, states move the way states do when instruments draw circles. Permits wrapped in new language, environmental caution, heritage protection, survey moratoria, tightened around warm belts. Drone flights filed clean plans and came home early with footage of fences that weren't on any public sheet. A line on a consultant's thermal map became a line a convoy would cross. The hum under sand turned into a rule in a ministry. No high-energy sources in Zone B, no exceptions. For the crews who still walk those grids, the takeaway is simple. Heat and hum aren't decorations on the story. They're the part that touches wrenches. A system that warms where it shouldn't and sings when its quiet wants to keep moving water on its own terms. Listen wrong and you'll break it. Listen right, and you might learn how to borrow its patience without stealing its future. The invisible treaty, zones, denials, enforcement. While crews were teasing heat and hum from the sand, chancelleries were redrawing emptiness. On public maps, the Sahara stayed blank. On internal overlays, rectangles appeared, hushed corridors where surveys paused, permits slowed, and pilots learned new shapes of no. Nobody called it a treaty. Everyone acted like one existed. Stakes are simple. Blank spaces mean veto power. If a corridor is off limits, whoever polices it can shape where steel enters the ground and where it never will. In a transboundary aquifer, that's sovereignty with extra steps. Get it wrong and you light a fuse, drills in the wrong window, head falling in the wrong district, neighbors pointing at each other with dry taps in their hands. Action starts in the late 20th century language of cooperation. Post-colonial borders hardened, then softened at the edges where sand made officials pragmatic. Quiet memoranda traded between Cairo, Khartoum, N'Djamena, and Tripoli spoke of survey moratoria aligned with sensitive hydrogeological corridors. The phrasing was environmental, the intent strategic. You find lines like, pending joint characterization, no high-energy source surveys within Zone B to avoid destabilizing confined heads. That sentence is a fence. Enforcement looked like weather at first, random denials, lost applications, but it patterned fast. An archaeology team with a clean record filed for ground-penetrating radar in a wadi near a known damping ring. The permit returned stamped, deferred due to cultural heritage review. 6 months, no review. A hydrology lab proposed shallow refraction transects across a suspected pressure window. The liaison suggested alternative sites of lower sensitivity. Translation, not there. A private drone outfit filed a flight plan to update dune migration models. They received a call at dawn. Area active, resubmit next quarter. They didn't. On the ground, convoys turned. A French-built survey truck with Chadian plates rolled toward a rectangle's fringe and found a checkpoint manned by men in boots with mixed accents and no insignia. Papers were in order. The commander smiled, said the road had washed out, desert, no road, and pointed to a detour that added 2 days and veered wide of the ring. The drivers went where the gun barrels suggested. Unknown to them, across the border, a Libyan patrol told a similar story to a Sudanese crew with a brand-new gravimeter. Drones came home with their bellies empty of images. Operators swore they flew clean. Logs showed altitude shifts and geofencing boxes that didn't belong to any public NOTAM. In one case, a quad fell from the sky as if it had flown into wool. The vendor blamed firmware. The pilot blamed a jammer that didn't hum so much as smother. A week later, a contract appeared for communications masts along a barren ridge nobody had reason to talk across. No declared users, tall fences. Economics wrapped tight around the silence. In ministries, water became the last resort sovereignty play. Egypt eyed the Nile's upstream projects and felt the room shrink. Inland head looked like insurance. Sudan floated paper for food corridors that would ride pumped desert water to stable towns. Chad lifted a phrase, resilience through oasis stabilization, straight from a donor's brochure and stapled it to a plan to hold people where pasture still breaks the wind. Libya, rebuilding, wanted its pipes safe and its wells deeper. Algeria buffered borders with caution and long memories. Each drafted policy with one eye on the neighbor and one ear on a phone that sometimes clicked. Security logic hardened the edges. Smuggling lanes had long threaded the dunes, moving fuel, cattle, people. Now they braided with radar gaps and patrol schedules. Foreign advisors showed up at remote posts with antennas that pointed nowhere local. Procurement lines in multiple budgets spiked for long-endurance UAVs, desert perimeter lighting, acoustic monitoring arrays. The arrays were sold as anti-smuggling tech. Crews who'd heard the hum called it something else. An ear pressed to the ground to know who was walking where and with what. Paper hints told the rest. A tender in one capital called for hydrostatic monitoring towers without any public reporting requirement. Another sought regional telemetry harmonization with no listed partners. A third contracted heritage site perimeter control around coordinates that matched a damping ring's outer belt, though the listed monument lay 100 kilometers away. Names moved, rectangles stayed. Denials came cloaked. One geophysics professor submitted a multi-country proposal to map gravity at higher resolution across the borderlands. Reviewers praised the science. The funding agency wrote, "Excellent but field risk unacceptable at this time." A private consortium pitched low-impact electromagnetic reconnaissance with a sensor suite designed to avoid strong sources. The reply, "Export clearances pending end-user certification." The end user was the government that wrote the request. Meanwhile, enforcement wasn't always a uniform. In one ring's shadow, a smuggling crew flagged a scientific convoy in the dark and told them to turn back. No threats, just a statement. "Bad wind ahead, you don't want to camp there." The driver read the room and turned. 2 days later, a military spokesman denied any operation in the area. Both were telling the truth in their lanes. Impact lands and behavior. Researchers self-censor proposals to avoid the rectangles. Vendor brochures blur specs that might trip a review committee. Insurance firms raise premiums for any operation that lists certain coordinates, then offer discounts if a client hires liaison services staffed by the same ex-officers who once ran the checkpoints. Universities train a generation of hydrologists to talk about regional aquifers without ever saying Nubian Sandstone Aquifer System and strategic windows in one breath. Why an invisible treaty instead of a shouted one? Because public agreements invite public timelines, and none of the actors want a clock running on fossil water they can't refill. Because a signed map with rings would turn distant rectangles into domestic politics. Because ambiguity is a currency in deserts where borders are flexible, and silence keeps options open. Yet the silence screams when a drone falls, a convoy turns, or a permit smiles and never arrives. The rectangles are there. They cordon the belts that hum and warm. They say, this ground is not for amateurs, not for fireworks, not for maps you can download. 5 nations understand the stakes and enforce them with denials that never admit their target. And still under the quiet, each sketches taps and pipelines in pencil, ready to erase or ink when the weather, political and otherwise, turns. 5-country play, motives, methods, risks. While the rectangles hardened into habits, planners in 5 capitals ran the same calculation with different endings. The aquifer doesn't care about flags. Budgets do. So each country sketched a play that turned pressure into policy, always with an eraser nearby. Egypt reads head as hedge. The Nile is a single spine with many hands on it upstream. Insurance lives west under sand. Motive, redundancy for cities and leverage for farmers if river politics pinch. Method, expand western desert wellfields in arcs around existing oases, couple them to modular desal on the coast to mix brine and fossil for a stable blend, then pipe inland so pumps don't carry the whole weight. Papers speak of oasis stabilization belts and desert-to-delta corridors. Quiet tenders ask for high-lift, variable-speed pumps with soft start controllers, gear chosen to avoid slamming heads. The risk file is blunt. Overdraw near shared windows and you lower your own hedge. Tap the wrong belt and you trip the invisible treaty. Sudan's motive is leverage and food. Rain patterns fray. Fields need reliability, not miracles. Method, cluster drilling along known transmissive streaks in the north, favor shallow lifts first, pair with gravity-fed canals that hug old wadis, and build grain storage on the nodes to smooth shock years. Financing runs on stitched-together grants, Gulf credit, and barter, fuel for water. Bids land for solar-augmented pump farms that promise power where the grid can't reach. Engineers push distributed taps over megapipes to keep politics local. Risks stack anyway. Subsidence where clay's compact, salinity creep in badly lined fields, and drawdown that crosses lines and lights arguments they can't afford. Chad plays for survival. The downstream memory of Mega Chad is a basin with ghosts and little cash. Motive, keep people in place with reliable wells and a few irrigated belts so roads remain roads, not escape routes. Method, target the safest windows, pressure without brittle caps, using borrowed gravity data and donor-supplied them, then drill modest and many. NGO reports talk about community-managed boreholes with telemetry that pings satellite every dawn. The state folds that data into a control room with 2 screens and a generator that sometimes starts. Risks aren't abstract. If a head falls because a neighbor pulled hard on the same plane, villages migrate. If a gallery collapses because a contractor chased cheap casing, a district loses trust in maps forever. Libya is rebuilding a spine. Motive, restore flow to cities, deepen resilience inland, and prove that the great man-made rivers idea survives its wounds. Method, recondition wells in Sarir and Tazarbo, add redundancy through parallel trunks, and trial deeper completions where transmissivity holds, always balancing lift cost against head. Contractors pitch leak detection that listens for the low note along the pipe. Crews petition for better screens to fight fines. Paper trails show bids for thermomonitoring at vented risers, a phrase that hides the hum inside compliance. Risk sits where it sat before. Infrastructure as target, single points of failure, and the temptation to overpump sweet spots that answer quickly and then fall silent for years. Algeria isn't a headline owner of the Nubian Sandstone Aquifer System, but it shares fringes and borders with every risk. Motive, buffer instability, manage trans-Saharan movement and keep leverage with caution. Method, limited reconnaissance along border belts, strong say over any foreign kit that smells like deep mapping, and quiet cross-notes with neighbors about heritage buffers that double as hydro fences. Vendors learn to sell environmental baselines that happen to avoid the rings. Risk is political as much as physical. Say yes to one aggressive tap next door, and you inherit a route you didn't plan to police. Across these 5, a sketch of pipelines and taps appears in pencil. Egypt's corridors nose toward inland logistics hubs. Sudan's canals faintly reenact paleo drainage. Chad's dots cluster where roads can still bring salt and soap. Libya's trunks thicken where valve houses already rise from the gravel. Algeria's absence is a kind of presence. Veto power by denial. Financing writes its own subplot. Sovereign funds promise resilience capital. If outputs can be metered and sold, water for fuel swaps, crop offtakes pegged to head curves, insurance tranches that pay out if drawdown beats projections. Off-books contractors, those firms that move between flags, offer turnkey desert greening modules with proprietary pumps and telemetry that phone home somewhere else. The sales pitch slides a new phrase onto the table: energy-positive lift. A pump that feeds on head and heat, amplifying with a whisper of outside power. No specs, non-disclosure walls. Brokers say, trust the demo. Engineers don't. They ask for curves. Head versus flow, power versus lift, maintenance against fines. A few agree to closed pilots in fenced rectangles where hum and warmth complicate baselines. If a thermoacoustic assist exists, it'll show in the long note and in slower clogging. If it's smoke, a farmer will pay in diesel by spring. Risks braid across borders. Drawdown backlash travels faster than trucks. A cone that bites in Kufra can thin a spring in Egypt's outback. Subsidence can break a pipeline that feeds a city that feeds a protest. Salinity creep doesn't care about speeches. Displaced people move along the same lane's smuggler's map, and every checkpoint learns a new prayer. So the five-country play reads like this: hedge, feed, endure, rebuild, buffer. Methods vary, physics doesn't. The hum under sand sits in the margins of every memo, a rumor that's also a measurement. And just off the last page, a consortium keeps whispering about energy-positive lift, the machine hypothesis where the rectangles what could hum under sand. We've got rings that dampen, vents that breathe, belts that warm a little at night, and a low note that reappears when engines die. If this isn't only geology, what kind of machine could live under sand for millennia without gears, fuel, or wires, and still have a pulse you can feel on a still night? Start with the quietest engines we know, ones that borrow heat and pressure and pay them back as motion. A geothermal siphon is the simplest sketch. If a confined aquifer has small but real thermal differences, warmer pockets at depth, cooler lenses above, then a looped conduit can sustain circulation. Warm water rises, cool water sinks, and the loop breathes forever as long as the gradient holds. Scale that to galleries tied into annular rings, and you get a mesh that moves without pumps, guided by head and temperature alone. No magic, just a patient delta between warm and cool. Layer in a thermoacoustic assist. A long cavity with constrictions can convert tiny temperature swings at vents into pressure oscillations. Think of a Helmholtz resonator asleep under a dune sea. Night air drops through a vent, cools the neck and shifts density. Day heat reverses it. If the cavity is tuned, volume here, throat there, the result is a low-frequency pulse that stirs boundary layers and discourages settling. It won't power a town. It doesn't need to. It only has to keep the galleries from going still, the way a sleeping animal's breath keeps lungs clear. Add RAM behavior where head concentrates. In places where the confining layer has windows, a falling head can be staged through narrowed throats that behave like soft RAM pumps. Each pulse, however small, lifts a sip higher along the ring while waste pulses dump into rectilinear spillways. Over a season, sips add up to flow that looks steady at the vents, even if the machine inside runs in slow beats you'd only catch with a patient seismometer. Materials don't have to be exotic. Stone throttles, ceramic sleeves, lime-sealed joints, and thin copper skins where trickles would otherwise grow slime. Every component is within reach of desert craft bolstered by trade. Basalt for dense plugs and wear faces. Well-dressed sandstone for wall segments that accept compression without splintering. Fired clay for repeatable geometry. Copper as a thin lining that discourages biofilm and scales, placed only where it matters. Durability comes from overbuilding throats, armoring spill lanes, and giving every pressure rise 2 exits so nothing sees an unkind spike. Control is the part that sounds like myth until you watch farmers manage water with sticks and stones. A stone valve isn't a wheel, it's a calibrated plug. Lift by 1 notch etched on the seat and you admit a known increment of head. Lower 1 notch and you bank pressure for downstream neighbors. If alignments on the rims function as clocks, then maintenance follows the sky. Crew at the northeast riser clears silt when the star clears that marker. The opposite team moves 2 weeks later, keeping the ring balanced by habit rather than command. Tradition is a controller that never loses power. Now test the hum. Those passive seismic bands near a few hertz could be the cavity's preferred note. If vents are spaced at quasi-regular distances and galleries form loops with gentle constrictions, the network will favor a small family of modes. Wind will drive some thermal breathing others. When an engine idles near a vent, broadband noise masks the note. Cut the engine and the mode returns. That's not mystic, just resonance emerging when the world gets quiet enough to let it ring. What about the warmth that lingers at night where no lava lies? Several answers can stack. Modest radiogenic heat at depth, insulation by dry dune sand above, and slow convection in a protected cavity can create a gentle thermal inertia that satellites red as a blush. If galleries run near confining layers, the system could shepherd that warmth along belts. Not hot, never hot, just a few degrees that matter in viscosity and in the stubbornness of flow. Could such a system be energy positive in the sales brochure sense? Not as electricity. As hydraulic work, yes, in the strict meaning that a trickle at higher head can be traded for more volume at lower head downstream with minimal external input. A modern team could parasitize that trickle with very small, high-efficiency lift assists, thermoacoustic stacks, vapor-driven pulsars, if they were patient and honest about scale. The desert pays in pennies, not bills. Promise too much, and you end up stealing head that keeps the galleries alive. How would we prove any of this without breaking it? Build falsifiable tests that respect the rectangles. First, listen, don't shout. Passive arrays around a ring's shoulder to map mode families over seasons, correlating with vent temperature swings and wind records. Second, measure gentle. Fiber optic distributed temperature sensing along shallow transects to catch nighttime inversions and dawn lags without drilling. Third, tug softly. At an agreed safe fringe, add a controlled, small amplitude pulse, mechanical or thermal, and watch for coherent echoes in pressure at distant risers. No explosives, no deep shots. If a mode field exists, the pulse will return on its schedule, not ours. Fourth, chemistry as chronicle. Sample microenvironments inside old vents, salts, biofilms, mineral varnish, to read flow direction histories and thermal regimes. Varnish thickness and isotopes can out-gossip any diary. Fifth, map geometry with methods that the sand forgives, gravity and low-impact M, to tighten ring closures and lane rectilinearity without hammering. Publish enough to earn critique, hold back coordinates that put field crews at risk, and layer governance from day one so a good result doesn't become a rush. The filter stays on, every claim gets a control. For each ring with a hum, find a ring-shaped mirage that doesn't sing. For each warm belt, find a basalt cousin that explains the signal clean. Keep the speculation in the margins until the numbers stand upright alone. If the machine is there, it'll tolerate being heard. If it isn't, silence will outlast our metaphors. Either way, the discipline matters more than the myth. A desert that hides pressure this well rewards patience. The only engines that last here borrow what the ground already gives and return it gently. If something hums beneath the Nubian sandstone, it's telling us how to move water without waking the sand. The breaking point, why it matters now. While we've been listening for a hum under sand, the surface has been getting louder. The Sahel's rains are slipping their schedules. Reservoirs that used to buffer a bad year now expose cracked margins in consecutive dry seasons. 3 years of near misses stack into one truth: margin is gone. In towns that once counted on a short storm to reset the clock, wells run late and end early. Bread prices climb on Thursdays and do not come back down on Mondays. Stakes aren't theoretical when a river's promise turns conditional. Upstream dams on shared arteries change the cadence downstream. Crops fail on alternating banks in alternating years, and patience thins on crossing roads. In that heat, migration stops being a headline and turns into feet moving north at night. The same tracks that smugglers mapped become evacuation lanes for families who have never seen the sea. Ports on the Mediterranean feel the pulse months later. Politics bends, fences get taller. Action looks like a ledger with red ink where weather used to help. Farmers shift to short-cycle grains that buy time but sell calories short. Herd sizes shrink into numbers that keep a family alive but cannot lift them. City taps run ration hours. Tanker trucks learn new routes at dawn. A ministry announces an emergency wheat purchase the same week. A foreign exchange crunch says no. Local officials authorize new wells without maps because maps take months and thirst takes days. Contractors drill where the ground is easy, not where the head is kind. A spring starves a valley. Nobody planned it that way. Meanwhile, food prices pull on politics. Subsidies widen then snap. Coups arrive packaged as corrections to shortages. Border posts tighten because the economics of hunger invite every trade, licit and not. Ports add scanners and soldiers. Insurance climbs for ships that carry basics to places where unloading may turn complicated. None of this is abstract if you're holding a receipt for bread that doubled while you walked home. Impact lands in circles. Dry fields feed frustration. Frustration feeds movement. Movement meets borders, and borders answer with force or with channels that need cash and calm to function. Cities already stressed by growth absorb newcomers with thin patience because the taps cannot flex. A generation that learned to read on a phone now learns to scan for roots. And in every meeting where someone says, resilience, a quieter voice asks, what if the aquifer really can carry us through 2 bad decades if we treat it like a patient rather than a prize? Choice arrives mean and simple. Unlock fossil water strategically or keep playing roulette with sky and river. If the Nubian Sandstone Aquifer System is a bank account written in deep time, any withdrawal needs rules. That's the argument in rooms that don't publish minutes. Open a limited number of windows where head can afford it, pair each with strict cutoffs and telemetry, feed towns that would otherwise empty, and buy years to modernize the surface. Desal, reuse, smarter irrigation. So the desert isn't asked to carry a century. Ethics refuse to stay quiet in the corner. Who owns a store that filled in the African humid period and hasn't refilled since? If we drink it now, who pays later? Is the later a farmer's grandchild or a neighbor? Sovereignty slams the table, our ground, our call, but groundwater ignores lines you can see. Debt across generations isn't just a slogan, it is a head curve on a chart with your family's name on the axis. Use now, and you lower tomorrow's options. Refuse now, and today's villages empty into roads that break cities. You can't not choose. Here, where the machine hypothesis stops being a riddle and becomes a warning label. If rings and vents regulate flow softly, if warmth steadies viscosity, if a low mode keeps throats from clogging, then hammering the wrong patch for quick volume is more than waste. It is sabotage. The invisible treaty drew boxes around that truth because nobody wants to wake a system that, even broken, still helps. If one belt links pressure across basins, a bad blast in one country becomes a dry month in another. Who explains that at a border? Now the pressure to move fast is real. A banker with a dashboard says, fund pipelines where head is highest. A contractor says, we can deliver liters per second this quarter. A politician says, open the tap before the election. Engineers tired of being the slow voice say, define maximum draws tied to measured head, not hopes. Fence the rings we already know hurt easily. Publish logs with safe lags so lies can't root. They're not asking for poetry. They're asking for a metronome. Tease one last knot. There's a circle we haven't named in public because it behaves like a governor on a much larger machine. Every actor knows the coordinate class. None will say it first. Smugglers won't camp there. Militaries steer around it. Papers about it read like they're clearing their throat. Disturbing it may cascade across a plane that carries more head than any single nation can afford to lose. That circle is the hinge of this decision. So we stand at a false ending that isn't false because it withholds magic. It's false because it pretends standing still is an option. It is. Drought won't wait. Prices won't wait. People won't wait. The only honest path is caution with action, pilots that measure before commitment, governance that cuts pumps when head says stop, transparency that buys trust because secrets already cost too much. The unresolved circle stays unnamed for now. What we can name is a way to test without breaking what might be keeping us alive at night. The unmarked circle, one coordinate off limits. There's one circle everyone steps around without saying why. It sits where 3 patrol maps overlap and none of them print. The stakes are cruelly simple. If that point is a governor on a shared plane, a careless drill could drain strength out of basins chained to it. Every actor feels the temptation. One valve to feed a province, but the cost of a wrong touch could echo past borders and years. Action lives in composite reports with the name stripped. Night wind that walks in a corridor when the desert should be still. Radio that loses its voice, not in static and hushed. Compasses that don't point wrong so much as hesitate. A low tone you only notice when the generator dies and conversation stops. Smugglers detour with no story, just a rule. Soldiers post a checkpoint 2 ridges away, then swear the ridge is the reason. Impact is enforcement by culture and chance. The circle is an informal no-go, held by people who never met but learned the same lesson. Don't sleep there, don't dig there, don't test big there. Geology might explain a piece, subtle heat, a fragile cap, but behavior filled the gap the maps left. Disturbance here could cascade through pressure windows that feed towns you'll never visit. Decision then? We withhold the exacts. Instead of disclosure, we propose safeguards, mapped buffers with independent sensors, seismic quiet zones by law, gradual probes with public logs and hard cutoffs, and an audit trail that can't be edited in wartime. Move from secrecy to pilots that protect people and data. If the circle is a key, treat it like one, kept safe, turned rarely, never forced. Safeguards, pilots, and proof, what to do next. We don't get to choose uncertainty, but we do get to choose discipline. If the desert is humming, we meet it with safeguards that turn rumor into measurement and appetite into rules. 3 pilots. No fireworks, everything logged. If it can't survive a logbook, it shouldn't touch the sand. Pilot 1 is monitored extraction at the safe fringe, where head is generous, caps are thick, and the damping rings are faint. The goal isn't volume, it's behavior under a microscope. 2 to 3 new wells, each completed to strict standards with conservative screens and gravel packs that respect fines. Pumps set to soft start and capped below the aquifer's easy yield. Every well collar gets a sentinel. Pressure transducers reading continuously, fiber optic distributed temperature sensing running along shallow transects, and microseismic geophones set back far enough to hear without shouting at the ground. Public dashboards that publish with a safe delay, weeks, not minutes, so field crews don't become targets but critics still get to watch the curves. Head falls beyond a preset slope, automatic shutdown. Chemistry creeps beyond a defined window, slow the draw. No exceptions, not even for speeches. Pilot 2 is seismic quiet mapping, listening campaigns designed so the sand never hears a hammer. You lay passive arrays in concentric arcs around a known ring shoulder and let them sit for seasons. Correlate low-frequency modes with wind records, vent temperature swings, and barometric drifts. You pair that with gravity and low-impact electromagnetic transects that fill in geometry without stirring it. No explosives, no deep vibe sweeps. Every instrument sits on mats to decouple from footfall rumble. Every deployment logs noise sources religiously. The aim isn't a pretty picture, it's a testable map of which modes belong to the ground and which are just the weather wearing a mask. Publish the mode families. Invite insult from colleagues. Revise. If the hum fades when you crowd it and returns when you go still, write that down and design around it. Pilot 3 is governance baked into the pipe from day 1. Community water credits that make local eyes the first and best enforcement. You meter every liter that leaves a pilot well. You publish running balances that show not only what was taken, but what remained against a community's agreed cap. You route benefits through a ledger that credits households, farmers, and schools directly. Leaders convert to entitlements that pay for maintenance, for leak detection, for audits. If a pump overdraws, the ledger bleeds red on phones long before a far-off ministry remembers your name. Tie escrow to honesty. Funds flow only if sensors stay alive, logs stay public, and auditors sign off. Make transparency a paycheck, not a sermon. These aren't ideas alone. They're kit lists and checklists. Independent audits ride alongside government crews, mixed teams from universities in neighboring countries, regional institutes, and a small circle of vetted international labs with no equity in outcomes. Every sensor has a twin from a different vendor. Every dataset has a checksum. Every field note, even the ones that say cold air, lives in a repository with a clock that stamps it before politics can. Each country hosts a node. Each node sees the other's graphs with safe lags. If a curve kinks in one district, the rest feel the tug in hours, not months. We flip incentives while we're at it. Right now, silence is a commodity. We make openness worth more. Insurance discounts tie to public data streams. Grants unlock only if you can prove you denied permits inside the known rings and published those denials. Contractors bid on transparency as a line item. How they'll document, how they'll fail safe, how they'll pick up the phone when an independent geophysicist pings them with a question they didn't like in the press. If you want to work in the rectangles, you bring receipts. Then there's the delicate ask, measure resonance without breaking it. At the safe fringe, build a tiny pulse, mechanical, thermal pressure small enough to hide under the desert's own breath. A metronome's tap, not a drum. Time it to avoid wind. See if distant gauges twitch in rhythm. If they do, the mode family is real and the network breathes as a system. If they don't, we learn something too. Some rings are only echoes of geology, not parts of a machine we'd be fools to touch. All along, we keep law close. Seismic quiet zones become written policy, not just whispers at checkpoints. Heritage designations cover the rims and risers that read like calendars. No high-energy sources within belts where passive arrays say the mode is strong. Hard fines and fast cutoffs. A standing cross-border panel, small, technical, dull on purpose, holds veto power over survey designs that might wake the sand. No politician can waive those rules for a ribbon cutting. The human side gets equal ink. Field crews sleep inside buffers, never on the rims. Smuggler routes that double as informal enforcement get mapped discreetly and respected as warning systems, not enemies. Local guides earn hazard pay and the right to call off a day if the air feels wrong, no questions asked, logged as local veto, valued like an instrument reading. If a herder says fires burn blue at the edge tonight, that's a data point with weight. Funding follows fear and hope. We harness both. Sovereign funds buy resilience tranches that vest when transparency targets are hit. Donors back the dull work, calibration labs, sensor depots, training that protects every glamorous pump photo from becoming a future apology. If a company shows up with energy-positive lift, they land inside a fenced pilot with independent meters and the understanding that silence voids the deal. In the end, the plan is modest by design. 3 pilots, a web of ears, a ledger that pays for truth, and laws that tell field crews. The ground decides, not the calendar. If something hums, we'll hear it carefully. If it's only stone, we'll prove it gently. Either way, people drink today without stealing tomorrow by accident. Under the dunes, time holds pressure, and it's asking for patience, not haste. If we listen with discipline, this desert can teach us how to drink without breaking what keeps us alive. Subscribe if you want to follow the pilots, the audits, and the fights over silence versus sunlight. Watch our deep dive on Libya's great man-made river next to see how fast buried water rewires power and why careful hands matter now.